Okay, thanks everyone for joining. You have joined the Hyak tutorial for how to use R and RStudio on Hyak. And I should say that this is just one method of using R and RStudio on Hyak. I will briefly mention another method, but it is possible that as with R, there are many ways to customize your R user environment, your R experience, and what kind of connectivity you need to other software. And so there might be other solutions that we have to accommodate your lab groups in particular, and that can be a longer conversation if you open up a ticket or if we can start, kind of like a few maybe lab meetings to get that worked up. But today we'll be talking about how to run R through containers. All right, and so if you haven't been to one of these workshops yet, I'm Kristen Finch. I'm the staff scientist with the Hyak team. I'm a facilitator, and so I'm the person that's behind the help desk if you're asking for, how do I do this? How do I do that? How do I install this software that I like or that software? It's usually if I'm, in town and available, I'm probably the one that's taking those tickets to help you through that. And I really enjoy it quite a lot. Before being the staff scientist, joining this job in March of this year, I was a postdoc in the biology department, so using bioinformatics and machine learning and conservation genetics. And so I was a user in the community before having this role. So I hope that, I get to bring this kind of two sides. Like I'm a former user, so I hopefully among my team can be a good representation for the users in our community. And so this is the last of our August workshop training series, but I will be bringing more training starting in fall and then in through winter and on. And we will have a post-workshop survey, which if you would be able to fill that out, it helps us tremendously be able to adjust the workshops. I've already been able to react to some of your feedbacks in previous surveys and try to make adjustments to the workshops like this one today. So Kyla, if you could please put that into the chat. Did anyone have a question there? Okay. All right, so our learning objectives for today are to understand Hyak software policies, become familiar with containers for R and RStudio, use SSH port forwarding so that we can use RStudio graphical user interface on Hyak, and we're going to become familiar with methods to creating your custom R and RStudio containers, as well as testing out the Rscript function for running longer jobs on Hyak. Before we get into the content, I want to make sure that we all are ready to be logged in. And so today we're actually going to be using multiple terminal windows. So as you can see here, I have 3 terminal windows opened up. One of them I'm just going to leave as connected to my local computer. I'll put it over here. It's going to go behind the web page. But these 2, I want you to go ahead and get signed in to Hyak. And the way that you do that is to start with SSH and then your UW net ID. So mine is Finch KN. And then @clone. Oh, I guess I should make this bigger. So if you have a terminal on Mac OS, you can use command with the plus sign to make that bigger. And then .hyak.uw.edu. So SSH Finch KN @clone.hyak.uw.edu, or with your UW net ID, of course, don't use mine. It won't work for you. And then my password. There's a security measure that it just puts your little key cursor there so that it hides your password if anyone is looking over your shoulder. But just use your muscle memory and trust yourself to get your password correct. Like I said, I'm going to go ahead and sign in with 2 terminals, and we'll use the other one a little bit later. Hopefully it'll stay active. So SSH again, your UW net ID minus Finch KN at clone.hyak.uw.edu. And then your password. And Duo two-factor authentication, all of this is required to sign in. All right, and so we're gonna be needing to, I'm just gonna like hide this one over here behind the web page for now. But just keep that open on your computer. We'll use it again in our demonstration. So I've got my one terminal open with my shell looking at clone at the login node. So this is my username at clone login. This means I'm in the login node, and the tilde is shorthand for the home directory. So this is the directory where you start working from. If you use pwd, you can have the absolute path to where your home directory exists on the file system of clone. And so if you had a graphical user interface like File Explorer or Finder in Mac, you'd be able to click through and kind of go through the files. But on the command line, you can use commands and absolute paths to get to the location where you want to be. But everyone should have something that looks very similar. All of the home directories exist in mmfs1/home, and then they're named after your username. So let's go ahead and start a job on an interactive compute node. And the way you would find out how to start this is you can use Hyak alloc. And this will show you what accounts and partitions are available to your username. And so I'm part of UWIT, so I'm in the UWIT account, and I used to be part of the Wasser lab, so I have a Wasser account, and then these are the partitions that I can use. So if I were to log in to a compute partition, my command would look something like this. salloc, that's the command to pull up an allocated interactive compute slice with our job scheduler called SLURM. I could say --account if I have more than one account, which I do. If I wanted to only use the UWIT account, I would do it this way. If you only have one account, it will default. So that'll work for you if you don't use that at all. And then partition, again, partition, okay. Then you might have multiple to choose from like I do. You might just have one. So maybe I can use this CPU G2-memx for 2x memory. I would just copy that and paste it there. Additionally, you could have just a CPU G2 is an option, or compute. Really, you want to look at this table and find out what your partition is. If you're using a GPU partition, you would also put that in here and start with your typing out your GPU partition that you have, for example. But anyway, I'm just going to use compute, and then --CPUs per task equals 1, and --mem equals, we only need really like 20 gigs. And then --time, let's go ahead and just do 2 hours so that we have this at least for our entire time. So if you have a partition that you can use like this, then that would be what your command is. If you're using a demo account, then your Hyak alloc would look something like, Jeff, I'm just going to use yours because I think it's still showing your demo account here. So Jeff, you only have a demo account. Yeah, so if you have only a demo account, then yours would just have this part of the table down here. And your salloc would look a little bit different. You could do just salloc and then --partition equals. If you all with only demo accounts could please use checkpoint-all. I've been forgetting about this, but we actually have a checkpoint that's just our Cascade Lake processors. And then we have checkpoint-G2, which is just the AMD processors, or our second generation of processors, the newer slices that have been added to our resources. But checkpoint-ALL, it is the largest pool of community idle resources available. So if you only have a demo account, if you would please use checkpoint all, and then --mem, you could still do 20 gigs, and --time equals 2 hours again. I think the CPUs per task default is always going to be 1, but you can just go ahead and tell it to be 1 as well. So anyway, that's what that would look like. I'm going to backspace and go to the compute partition for myself so that I can save those checkpoint partitions for our users that need to use checkpoint so that they can get onto their job node very quickly. Oops, I only set it up for 2 minutes. So I'm just going to exit and that will relinquish that and then set it up for 2 hours. Instead, and then, oh yeah, CPUs. Does anyone have questions? Is this working for everyone? Anyway, if it's still taking a little while, it's okay because I have stuff to talk about in the meantime. Mine is already ready to go, but this is kind of what you're looking for, your username at a different host, not the login node anymore. So my job was assigned to 3000 N or compute node 3056, but it could be a different one. If you only have GPU, it could be a G node, and then this is the job ID that was assigned. Excuse me, to my job. So now that that is all set up, I wanted to point out, so Kyla, could you please share the workshop materials in the chat? So this is our documentation website, hyak.uw.edu. If you click on the documentation tab and you go into tools and software, this is the information that we're going to be following today, R and Rstudio, written out in a nice format. Although today, since you're attending this workshop, you're going to get a little extra stuff in here. So there's going to be a few more containers that we're going to use and a few exercises that are not included in this written format yet, but they will be added later. So what I wanted to say is that part of this is to have an understanding of Hyak software usage policies. And so a main tenet of Hyak is that it's a shared user environment. And so we really try to make a user environment that is as broadly applicable to the most researchers as possible. And so we try to keep it as minimal, really, as possible. Another reason is that we actually load the operating system on each of the nodes. And if we add too many softwares that are kind of automatically part of this node image, then the node images start to take up more and more memory of the nodes themselves. So it's our prerogative to keep that very light. And so we put the ownership of what software to install onto our users. And really, it makes a lot of sense because you're responsible for your research. You're responsible when you write a paper about this to report, all the versions of software and everything else, and to provide some level of reproducibility, maybe not necessarily of your results exactly, but how you reach those results. And if anyone else wants to apply what you did to their system, then they would be able to do that. And so we really put a lot of the responsibility onto our users to be able to set up their user environments for themselves, but we're of course here to help. And so we have the help desk, which is if you email help@uw.edu and you put Hyak in the subject line, that's where you can describe the situation that you're finding with your software. And if you need help installing that, then we can help you with that. I mentioned a little bit that we're going to be talking about software containers to run R. There is another method available to run R, which is called modules. A module is just a way for you to load, trying to talk and spell at the same time, load the software environment that you've installed into your user environment. So it makes all the commands available to you if you were to load a module. I looked at the module list. So if you do the command that I just did, which is module avail, it's only available on an interactive compute node or in your batch scripts as well. then you'll see all the modules that are available. Up here at the top, in this folder, the SW/clone, these are the software that we have loaded for you. These are very broadly applicable software that are more difficult to install. And so these are the things that we maintain. And then down here, all of the labs have their own space where they can store their module files as well. And then some of them are publicly available and some of them are not. And I did see that, for example, the STF partition has an R module, but it hasn't been set up completely. And then there are a few other labs which have their private R modules. And so it could be that we need to have a bigger conversation, and I might offer a modules workshop in the future. It's just another way to install software for your user group and then to load that specific user environment with the module software called LMod. But it's outside of the scope of this this talk. But if you are a lab that your RStudio needs to be able to contact other software, that could be a conversation that you want to have with the Hyak team on if your RStudio needs to contact a lot of other software. One option would be to also install those softwares into the containers that I'm going to talk about. But anyway, it might be a bigger conversation, and I'm open to having that conversation with any labs that need to set up a custom R environment. But today we're going to talk about software containers. Kyla, if you could please put the link to YouTube where we had our container tutorial last week. A lot of this will be a review, but software container is a lightweight, isolated software environment that encapsulates an application along with its dependencies and runtime settings. And this can be useful to provide a consistent and reproducible way to package, distribute, and run your software across different computing environments and across different operating systems, for example. So you can have, what we're going to be using today is all of our R containers that we're going to be talking about are actually built on Ubuntu, but then we're running a Linux environment on Hyak, right? So that's a perfect way to be able to do this. And here's just a little diagram. So this is kind of how a container, how you can think about a container. We have our infrastructure, which is Hyak clone. So this is actually the hardware and the network of servers that are all in the clone ecosystem. And then we have our host operating system, which is Rocky Linux. And then on top of that, we have our container running software, which is Apptainer, which is a container running software that is suitable for HPC. And then you have your apps plugged into that. And so if we're thinking about today, like R and RStudio are apps that are plugged into this, this whole structure here. So why use containers for R, though? Like, it sounds like just an added level of complexity. R is already very complex. I am an advanced R user. I've used it for my research for many years in academia. And, you know, why should I have to struggle with this? Well, the struggle is worth it, friends, seriously. So R is an open source environment, as you know, and the dependencies in R versions are continuously changing to where even if you just update the version of R on your local computer, you could find that your scripts aren't running anymore, or some function has been updated, or there's a new dependency for the new version of the software that you have to install, or you have to update all of your packages. And so one thing that you can do with using a software container or multiple software containers for R for specific projects is that you can control and have a preserved R environment without running the risk of updating something and then having all of these like cascading effects of changes that also need to take place so that you can run your software and do your R analysis. That's my favorite part about it. Another thing is that you can publish that with your paper, and now someone else can pull that container. Maybe you've pushed it up to a container repository, or you've shared it on Dryad, or another way that you could share it when you publish your your manuscript, and then they're able to run that same R environment. They're able to run those scripts and know that they're going to work for them. Thirdly, is that some packages go completely out of maintenance. And so only a very old version of that package is even available at all. And it certainly doesn't run the current version of R, which might be R 4.4.1, which is the current version. And so you have to go back and find an older version of R to be able to run that package. Well, one way to do that is you find that version of R, install it into a container, install the package that you want and all of those dependencies. And now you have an isolated version of this package that you can use now. And I've actually gone through this personally, that there was a package that I wanted. It did exactly what I wanted. There was no new package, wasn't maintained anymore. And then I was able to make an isolated software environment where I can use it. Okay. Where is R in all of the R packages for a particular container stored? We'll get into that. So we'll get into that for sure. Let me finish this list. So the last thing I wanted to say, or two more things, R takes up a lot of files on the file system of Hyak. So as you know, every package has a different directory, and all of these counts as separate files on Hyak. And you know that your lab quota only has like a maximum number of files that you can even have stored in your lab's storage area on Hyak. And a container just counts as one file. And we'll talk more about how that is structured. And then finally, you can share these with your lab. So for example, you guys won't be able to see this, but the Wasser lab, we had a containers directory where we just had all of our containers. So we do have some R containers in here, like tidyverse. This is a custom R workflow. There was a paper that packaged an R workflow to look at mitochondrial genes, but they didn't publish a container. So I just made a container with the specific version of R and all the packages so that I could replicate what they were able to do. And then this was the Synbreed, was the old package that I was able to rectify as well. And so anyone in the Wasser lab can still use those containers, and they'll be able to recreate the analysis that I was performing when I was there. So hopefully you have now become an R container evangelist like I am. But I do want to say that you don't have to do everything yourself. So there are R containers already published on Docker Hub. I would say Docker Hub is, if you want to learn more about container repositories, please do look at the YouTube video of the previous training. But if you look up Rocker, so the Rocker project are these guys. It's actually, so these folks have decided to make different R containers, which are for different projects. And they can be good base containers for your custom R containers, which we're going to build, or they have containers that are pretty well built out. So if you start looking at some of these, they have a R CUDA container, they have Shinyverse, they have Geospatial R, they have R Edge. I don't know what that is. They have GDAL, Parallel, many different things. They have a tidyverse container. You can even run VS Code through R. I haven't played with all of these, but you should just know that this is a reputable publisher of containers for R, the Rocker project. And if you go to rocker-project.org, then they actually list their images. So if you click on any of these, you can go here and you can get an overview of what they have. They recommend to run it through Docker, but I'm giving instructions for Aptainer. But I think at some point they probably list all the packages that are available, or somewhere on this website they list all the packages that are available with the with those containers and even uses. So they have really great tools here for how to use these containers. And Kyla has just shared those two links in the chat for you. All right. So the Rocker project is what we're going to be looking at today. We're going to be downloading some Rocker containers. We're going to make them custom. So I'm going to show you kind of what it looks like inside of one of these containers, where your packages will be installed if you build a custom container, and all of that. So now, if you haven't already, please do use salloc to get onto a compute node. We did this at the beginning so that we'd have a jump start on getting that done. One thing I do want to mention is that we do have limited storage in your home directory. So if your username is showing your username at whatever host you're on in the home directory, I want you all to change to a different directory just for this tutorial where we have larger storage. So if you could please use change directory cd /g/scrubbed. Oop, too many slashes. And latency. Oh, is it back now? It looks like maybe it was just momentary. Let me all know if you're able. So what I'm trying to do is have you all change directories to gscrubbed, where we have unlimited storage. Okay, sorry, just, okay, a little bit of anxiety when we're all lagging like that. Okay, so what I want you to do is just for today, or if you already have a directory under your username, you can use that, but I'm going to make a directory with makedir or mkdir for myself. I'm going to call it Kristen F. All of you should call it something different, obviously, so that we don't all try to write into the same directory, which won't work. So you can use your username, or you can call it tutorial, I guess, or whatever you want. And now if I change directory to enter that directory, I have nothing in there. If I ls, and so one thing that I want to make clear is that when you're working on Hyak, you always want to be using storage in a way that is smart. If you are always going to be putting your R package libraries back into your R home or your home directory, then you're going to run out of storage very quickly. In our home directories, we have a quota of 10 gigs. And if you run out of that storage in that home directory, you're not going to be able to do anything else on Hyak. And so another thing I want to do is that we're going to make a place for all of our R packages to be installed. So if we're installing packages once we're inside of our container, this is where those are going to be installed. But like I was saying, the best way to maintain space when you're building your custom R container is that you can, while you're building the container, also install those packages, and that's how you keep them all contained within the container. But I'll show you how to do multiple things here. So just be patient, we'll get to all these things. First thing I want to do is to use makedir inside of that directory and make a directory called R. This is where our packages temporarily are going to be installed. And the way that we instruct R for our user on where we want our packages to be installed is that we use an R configuration file, which lives in our home directory, called .renviron. So if you could all please change directory back to your home directory using cd tilde. And if you already have, so if you ls-a and you see something that is called .renviron, which I don't have, but it would be somewhere in your directory. If you don't have one, then we're going to make one. If you do have one, then you can change it for now if you want to, or you can keep it the same. So I'm just going to go ahead and make a .renviron file. It's just going to be an empty file called .renviron. This is what R is going to be looking for to know where you want your R packages. This is the first step on our tutorial. Inside of this, we're going to make a variable called r_libs equals, and then we're going to give it the path to the directory that we just made. So r_libs equals in double quotes /g/scrubbed/Kristen_f/r. Close your double quotes. And then to save that, I'm just going to use Control+X. So like this symbol is saying, just Control+X to exit. It's asking me if I want to save this. I'm going to use the Y key to say yes. And then I can save it as .renviron, but if I've just pressed the return key. So now if I cat that .r environ file, I see that it has my rlibs variable saved. Okay, now I want to go back to my working directory in scrubbed. Mine is gscratch scrubbed finch kn. And that's where I have my R directory. The very first thing we're going to do now is we're going to pull one of our containers that we have available to us. It's just going to be the R base container. So if I go to Rocker, it's in here somewhere. Anyway, I'll tell you what it is, but it's listed here. Here it is, this one. So Rocker/R base. That's how you would find it. So if I click on this, this gives me more information about what is included in the R base container. So it's a pretty basic container. The way that you pull this to clone is with Apptainer, our container running software, which is only available on the compute nodes. So if we do Apptainer pull, the way to pull from Docker is to say Docker : // and then you give it the path of this repository, which is Rocker/R base. I'm just going to change this to day mode in case it's easier to see right here. So Rocker/R-base. And this is just going to pull the latest version of that container. It's going to take about 2 minutes, at which time I will ask you if you have any questions. And you can put them in the chat. You can unmute yourself and tell me if you have any questions right now. So the steps that go ahead and interrupt me, but I'm just going to keep talking to fill time. The steps we've taken is we have made a working directory in gscratch scrubbed where we don't have a limit on the storage that we can occupy. In our home directory, we do have a limit. That's why we're taking these steps. We've made our working directory for today, and inside of that, we've made a directory called $R, where we want our R packages that we're installing on the fly to be installed. And then to instruct R to do it this way, we've made an R configuration file in our home directory called .r environ, where we have our variable r_libs that's giving the absolute path to that directory where we want that to be installed. There is a default of where those packages will be installed if you don't instruct R on where to put those, and it's in your home directory, and we'll be talking about that. But as I was saying, the reason is that we don't want to run out of storage on our home directory because we can't do very much if that happens. Okay. Anyone want to tell me if they are at the point where their screen says creating SIF?
Mine does, yeah.
It does, okay. Should just be a little while longer. Yes, Logan, go ahead. Did you have your hand up, Logan? Or was you just to say, yeah, okay, good. Okay, do containers essentially negate renv? I think you, I'm not sure exactly. I think that there are multiple R environments that you can have activated. So I'm not sure. I don't have experience with that exactly. The main idea is that your R environment, which is inside of the container, is completely isolated if you have an R environment outside of the container. So in a way, yes, if you've activated the container, then that R environment is going to take precedent over the Rn that you have set up, or if you're using a specific function. Not quite sure exactly what you're referring to there, Devin. Okay, so now mine is done. So if I ls-ltr to show the most recent things that if I list my directory, then I see that I have r-base_latest.sif. And I can go into this container and see what is there. So if I use Apptainer and then shell, so I can open a shell inside of that container. And then I start just typing the container. Or actually, first, I want to bind the file system. I talked more about this in the previous containers workshop. But basically, the idea is that the file system is not visible to the container unless you bind to the file system. So all you'll need to do is bind /gscratch, which will give you everything. You don't have to go more in depth with that path. So if I'm binding gscratch, it's going to be able to find my .r environ configuration file so that it knows where I want my libraries to be installed. So r-base _ latest. So if I enter, now I see that my command prompt has changed to be apptainer instead of this Finch kn at, this is my outside of the container command prompt. Apptainer shows that I'm inside the container, and I can start R this way. So now I see my version of R, which was just the latest one that they had available to me. But if you'll notice, I don't have any libraries installed. So if I try to load R color brewer here, I don't have a package called R color brewer. And if I do the .lib P for paths function, this will show me that it has indeed saved my package library where I want my packages to be installed. These are the other default places inside of the container where it would install packages, which I'll show you how to install packages there later. But this container is not writable. So any packages that I install here will be saved in this directory, which is on the file system outside of the container. So if I do install.packages and I start with R color brewer, it's really just because I know it's fast and small and doesn't have a lot of dependencies. Then it will start to download, unzip, and install that package. So these are for packages that you're in the discovery phase of your research. You find that you need to install a package quickly. Otherwise, your container has almost everything that you need. Then you'll be able to do this. But you'll see that the next time you open up the container, if you do it this way with binding the file system, you'll be able to use this package again. I'll show you. So now if I do library R color brewer, then I don't have that error about not having that package installed. So I'm just gonna exit out of the R shell. If I do Control D, it will do that. Or if I do Q with open and close parentheses, it'll ask me if I want to save my namespace. I'm not going to here. And now I'm still in the container. So if I want to exit, then I can get out of the container. And now if I list what's inside of my R directory, I see that R color brewer is installed there. And as I said, I can use up arrow now to go into the same command that I did before with opening the shell, binding the file system, and going to my container. And if I start R, and now if I do library R color brewer, it's able to look inside of that R directory and find where that package is installed. So I can continuously use these same packages. Okay. I just want to show you that I'm exiting here again. Another way that you can get into R more quickly, maybe without going into the shell first, is you can use apptainer run -- bind gscratch and then your R base _ latest. And then if you just put R, the command R directly after that, it will immediately open up the shell into R with bypassing the opening up the shell. And then if you use Q and open close parentheses, it will close out directly back to the command prompt and the compute node without having to go back into the shell and exit. So it just removes some of those steps. But one thing I want to do now is I'm just going to remove. Is this what I want to do? Let me check my notes. I want to show you the default of where the packages go if you don't set up your underscore or R underscore libs in your R configuration file. So just to make the point very clear, I'm just gonna rm-r my big R directory. I can get it back later. There's only one package in there. So I'm just gonna remove this. It's gonna recursively remove my R directory that I had from before. So now it's not there anymore. I can recreate it, but it's just gonna be an empty R directory. So I'm just gonna clear my screen. Now, if I do apptainer run without the binding, so not bind gscratch this time, and I just put r base underscore latest .sif and then capital R to open up the R shell immediately. So it looks the same, but now if I do .lib paths, open close parentheses, now it's just the library paths that are inside of the directory only. Instead of my my R libs that I made before. So now when I install .packages R color brewer, it says this directory is not writable. So would you like to use a personal library instead? And so I'm going to say yes. And now it's telling me instead, I'm going to create your R inside of this path. So it's going to go back to my home directory, make a directory called R. Inside of that directory, a directory called x8664pc Linux new library /4.4. And so if I say yes, then it's going to install R color brewer there, which is fine in theory. But if you run out of space there, like I said, you won't be able to do anything. So if I quit here, and now I list -a my home directory from here, I can see into my home directory. Now I see that I have this capital R directory inside of my home directory. So if I do list big R and then x86, whatever it was, it was R, it was 4.4. Now I see that R color brewer is in that location, which again is fine, but it's better to not install all of your R packages there. But the even most better way of making sure that you're optimizing your space as greatly as possible, I do want to just say if I list the R directory that's in here, nothing is in there because I haven't done anything. The best way to make your custom R containers is if you can build the container with the R packages inside of it, so that up here when it was saying my library path, so that it can install the R packages inside of this library path, which only exists inside of the container itself. And now I'm going to show you how to do that. What we need to do is we need to make a container definition file based on one of the Rocker containers where we send instructions to install the package that we want. So I'm going to make a new file with nano. I'm going to call it custom R.def for definition file. So it's empty right now. All definition files always start with bootstrap, which is telling us the source of the base container that you're going to use. So we're not starting absolutely from scratch. We're starting from one of those Rocker containers that exists on Docker. So we're going to bootstrap from Docker. And then we give the same location for the repository on Docker, which is our Rocker R base. So we could just copy this over here, put it there. So Rocker/R base. And then %post. This is where we start installing our packages. So install R packages. But R is not open, right, when we're building this. So we have to use a command to send this install packages command to run through R, which already exists in this baseline container, which I have, which I'm calling with these two instructions. So what we do, we use the command rscript -e. And then in double quotes, we're going to put install, sorry, actually single quotes. It probably doesn't matter, but yeah, single quotes, install dot packages, open parentheses, open quotes, R, color, brewer, close quotes, close parentheses, close single quotes. So what's going to happen? It's going to pull a new version of this Rocker R-based container from the internet, and then it's going to run this command inside of R to install our R color brewer package. So if we control X to exit, and then yes to save, and then save as our custom r.def with the return key. Now if I ls-ltr, I have my custom r.def container, and the way we build our container with Aptainer is we use Aptainer build. And this is where we give our new container name, is the next part. So our new container, I'm going to call it r-base-brewer.sif for Singularity image file. Aptainer used to be called Singularity, and the names of the images, the container images, are still bearing that historical name. And then you give it your definition file next. So custom r.def. And then you let that build. And this one should be a little bit faster because there is an Aptainer cache where it already has some of these things downloaded. So it's just going, it might still take 2 minutes. Is everyone clear on what's happening now? Thanks. Any questions? Hopefully we're all, we have, you know what I should do? I'll go in with my second window and I'll go to my working directory and I will paste what was inside of that custom r.def into the chat. In case you're a little bit behind, you can copy it. There's that. The formatting might look weird in the chat. Any questions about what's going on now? Or are you all already container experts from last week's workshop?
For pros.
Pros, Jeff's a pro. Thank you. I will say that installing packages this way, the best and easiest way is when you're using the most current version of R, which has access to the most current versions of all the packages that you need, because this command to install packages has access to the internet, and it can install R color brewer and whatever dependencies it also needs from CRAN, for example. Or if you have bioconductor packages, if you're using the most current version of R is kind of the way that it's going to be easiest to making these containers. But sometimes you do have to install containers from source, and I'll talk about that in a minute. But as we can see, mine is complete now. So if I ls-ltr, I have a new version of the R base container. Instead of it being called R latest, which it is, it's also the R base latest container with R color brewer already installed inside of it. And so again, just to reiterate, inside of my R directory there are no packages installed. So I'm not taking up any storage right now in my R libraries folder because R color brewer has been installed inside of the container that I just built. And I'll show you what that looks like. So if we do Aptainer run, and then I grab this new name, I don't need to bind my file system right now. I can do that later, but just to show you, if I open up R immediately, It's the same version of R, library R color brewer. Oh, without an underscore. Then no errors means that it's installed there. If I do .lib paths, open close parentheses. So it's defaulting, like I said before, because I didn't bind the file system and that directory still exists from before. If I go and delete it, then this won't be here. But if we go here, so I have to exit R because I can't see outside, or I'm just not going to do it this way. But the user lib R site library, that's where the containers will be installed when you do the build. So if I ls/usr/lib/r/site.library. I spelled something wrong. Oh, it's local. So it's user local /lib/r/site library. I think this is where it is. Am I doing it wrong? Oh, it's because okay, I know what I did. Okay, so actually for this to work, for this exercise to work, you have to do apptainer shell and then do the rbase so that you're inside of the container. Sorry about that. Spelled shell wrong. Okay, I'm just gonna clear. So I'm inside of the container. So if I do ls/usr/local/lib r site library, I think this is where it is. R color brewer is installed there inside of the container. Because that's what I built it to do. All right, but let's say you have a more complicated problem. You have R packages, but you come across this R package that's amazing and you need to install it and you want to try stuff out before you have to rebuild your container or whatever. So you try install.packages and then that R container, and it says zlib missing, or some other operating system library is not available inside of the container, and you need to have that there. This could also very easily happen if you're using an R module and you don't have sudo privileges to install those operating system libraries on our Hyak system. You could run into this stumbling block of, I don't have the ability to install these. Well, you need to build a custom container. You can install those inside of an R container. And now I'm going to show you a different way to build a custom R container. Instead of pulling from the internet your base container, we could continue to build directly on this container itself and build from a local image. So the first thing I want you to do is to copy your custom r.def file, and I want you to call it custom r dash from local.def, like this. So it's just making a copy of that. So now I can see I have my original one and I have my second one here. So if I copy this and then go nano, and I'm nanoing into my second custom r from local.definition file. And now what I want to do, I want to change the bootstrap, because instead of going directly from Docker, we're going to go from a local image. And it's called r-base-brewer. So we're building on top of our base container where we've installed our color brewer. We've already done these things. So I'm just going to use Control K to delete these lines. And now I'm going to install packages to OS, to the operating system. And this is kind of long, so I'm going to put it into the chat that you could install these types of packages inside of here. So the formatting is kind of weird, but it's still going to work anyways. But what we're doing is, since we're the baseline is a Ubuntu operating system, we're going to get the list of applications and get their most current version. We're going to install some of them, and this is the list of the apps that we're going to install. So like I said, zlib is one that might be missing, glpk might be missing. So these all can be installed, and then you can include these things to remove the package, like archives and things that you don't need to have there anymore, to reduce the space that's taken up within your container. So another thing I'll do, I'll just copy this entire thing here into the chat. So if I control X and save this, keep it the same name, custom R from local.def, and then we build this again with the same command, apptainer build, and now I'm gonna have my new version of this. I'm gonna call it R-W for width -libs.sif, and then I pass it my new definition file I was just working on, custom r-from local.def. So now what it's saying is, the very first thing is it's going to confirm that this is a good image, and it's going to start installing all of the rest of the packages that I just asked for. And from there, you can try to install that package that was missing these libraries again. And hopefully, you won't run into any more issues. But if you do, the best thing is to just use Google and ask Google, how do I install whatever it is? And grab those instructions and put them right into your definition file and rebuild your container and see if you've solved it this way. Does anybody have any questions? Okay. What is the build line again? Right. I can go grab it and paste it. Apptainer build, and then you can call your container whatever you want, but I called it r-w-libs.sif just to show that this is a new image, and then you give it so whenever you're building a container, you always want to do apptainer build, and then the new name of the container, and then the definition file right after that. Any other questions? The next part is more fun because we're actually going to use RStudio, which I know is a big selling point for R in general. So just to review, what we've done so far is we have pulled the R base container from Docker to clone with Apptainer, and we have used that a little bit. We've installed packages in the moment with install.packages, and we've set up our R environment, or our R configuration, so that R knows where to install those packages. Then we customized our container, whereas instead of installing packages in the moment while we're doing our discovery-based science, we can build that image that includes the packages that we want. Next, from that same image that was custom already with the rcolor brewer package, now we've built on top of that, including all of these additional Ubuntu OS libraries, these development libraries. And yeah, that's where we are. The very last thing I want to say, if we can, I'm gonna just clear. If we nano into that custom r-from local.def, and we go down here to the bottom. Another thing I wanted to, this is just going to be an example. We're not going to rebuild this again. But if you did want to install R packages from source, you would do something like wget or curl and you would get your, you would find that on CRAN or whatever it is. So it'd probably look something like HTTPS:// CRAN path to repo for R color brewer. This is not real, everyone. This is just me making stuff up. Version x.x.x.tar.gz. So basically you would Google, R color brewer version, whatever you want. You'd find that on CRAN. You would right click and copy that link address, and you would paste it here after wget. You would download it. And then you would do R command install, which is the way to install packages from the command line. And then you would just take that name of that package archive and paste it right there. But when you install packages this way in containers, usually it's not able to go back to CRAN and say, hey, I also need this, that, and the other package. And so sometimes you also have to go get those packages and install them from source as well. And that's why I want to emphasize that being up to date on your R packages is the best way if you are staying current with R. Or once you have your custom container, you just keep working with that. If you do have to go back into the R archives, it is possible, and that's what I had to do with my anecdote that I was telling you. I had to rescue this R package that no longer existed. But anyway, we're just going to X out and move on from this. I just wanted to show you that that's what the command would look like if you wanted to install from source. All right, so we have on this web page done a lot of work to make in this part, using the RStudio container with the graphical user interface RStudio. We've made some scripts that are really nice for submitting this batch job and can help you to open this. So I'm just going to follow this and walk it through step at a time and talk more about it in depth. But to move on with this part, we have to copy some things to our working directory, which exist already on clone. So we're going to do cp/sw/containers/r/ and then we're going to use a wildcard to copy everything that's in there to here with the dot. So I'll copy this and put it into the chat. If I execute this and wait for it to complete, one of the things that I have put in here is the tidyverse container from Rocker, which is right here. And so this is actually the same R base container with RStudio, but also inside of that is all the tidyverse packages already installed. It makes a really great base container because, of course, you're going to want to use tidyverse, ggplot2, dplyr, all of these packages which are already installed there. And then I also included an Rscript and a data set that we'll use in a little bit. But this is going to be the container that we're going to use next. The next thing that I want you to do is to use this command that I'm going to paste into the chat. It's just wget from our GitHub repo, where we have a SLURM script that will help us to submit this, this command to start the job that's running the container that we're going to port forward to and use through our browser. So if I do wget https:// I'm just saying it so I go a little bit slower for folks who want to catch up. .edu/files/RStudio, all one word, -server.job. And all that's doing is going to our repository and downloading that with the link to download it. So if I ls-ltr, now I have the complete set of everything that I need, which is my Rscript, my data file, the tidyverse container, and this RStudio script. So now if I want you all to use Nano to open that RStudio script, and you're going to customize it for yourself. So RStudio server.job. a lot of this, a lot of these comments I've put in there so that you can follow or look into all of these bits and pieces on your own. But the main thing is that we're going to be submitting a job. The job name is going to be RStudio server. If you are a checkpoint only user or demo account, I want you to go over here and change the partition to checkpoint-all. That will give you the most resources to choose from. But since I have my own account, not a demo account, I'm going to do compute. Whatever you used earlier to send to start up the compute node is what I want you to use now. This is an option. If you don't have more than one account, then you don't have to do this, but I do. So I'm going to use my account uw.it. If you don't know what your account is, you can just leave that part out. And then it will just default to the account that you usually use. We can leave all of this, but just so you know, it's requesting a job for 2 hours on one node or one server, one computer with 4 tasks. So that's 4 CPUs and then 20 gigs of RAM. And then the output, it's going to save a file, and the file, it's using shorthand to save it. And it's going to be called RStudio server. So the shorthand %X is actually stand-in for RStudio server. It grabs the job name, whatever you put there, and then it's going to do underscore and then $J, and the J is actually going to be the job ID that is assigned when the job is submitted. And it's going to save this all to a file. We'll see what I'm talking about here, but that's what that line is doing. It's a little bit explained here. The next thing we have to change is our RStudio working directory. And we're going to change it to the working directory that we're using today. And mine is gscratch/scrubbed/Kristen F. So whatever you've been using today, put that there. And then lastly, we're going to use our different, our tidyverse container, which is tidyverse underscore v 4.4.1.sif. So I'll put this name of that into the chat as well. Tidyverse underscore 4.4.1 SIF. So what this is doing is when you open up RStudio, it's going to open up in the files pane. We'll see this in a second, to whatever directory you put here. So I want it to open up to gscratch scrubbed Kristen F. You want it to open up to whatever directory you're using for the tutorial today. And then it's going to be using the RStudio image file, which needs to be inside of this directory. It doesn't work well if you give it a full path. So just copy that to wherever, or this directory needs to be wherever this image is. We can work on it later. If that doesn't work for your lab at a different date, just fill out a ticket. All right, and then all of this is just setting up your RStudio session. So basically on the compute node that opens up to start up this job, it's going to build a temporary file where it's going to save some of your session info. And then same thing with this, it's just saving some variables. One thing is that during this could be a way that you can control a different R package directory. So if you want it to be the same directory as we've been using for this tutorial, then you would just set it up this way. If you wanted, for whatever reason, you can customize this to point your directory to a different directory for your R lives. So that's just setting that up. And then there's other things that we have kind of set up for you. But one part is that all of this section is going to print to the output file, and it's going to give us our instructions on how to accomplish the port forwarding to open up RStudio on our browser. And then finally, if you ever wanted to edit the apptainer flags that it's using, you can edit these here. But today we're just going to leave them the same. So the point to take away from this script is that it's submitting a job that's going to be running RStudio server, and we're going to port forward. So we're going to open up a port and connect our local computer to a computer that is running this job on clone, and you're going to be interacting with RStudio that's running on that computer within your browser. So we've made all of our customizations here. We can save this by Control X and yes, and save it under the same name as before. So now to submit that, another thing I want us to do, remember I have our other window open here. So if you still have active in your other window, I want you to turn on to monitor your queue. And the way that we do that is we use watch-n10. This is going to issue the SQ command, which is about to come every 10 seconds. So SQ-U, and then put your UWNet ID. So mine is Finch KN. You could put yours here. So when I open this up, I see up here it says every 10 seconds, that's the part of the watch command, -N10. It's resubmitting SQ-U, Finch KN. So it's showing me my queue in real time. And since I have this window that's already open on host 3056, it's showing me that I have this job going on 3056. That's the job that we've been using this whole time. It's been running for 1 hour. So if then I use sbatch and I submit this RStudio-server.job, so it's given me my job ID, and now I see that that has just started the job here, and it's running on host 3371. Yours is probably running on a different host. If I ls-ltr, then I see now, this is what I was talking about with that output file. I have a file called that has my job name, RStudio-server, and then the job ID. So if I copy the name of this so that I concatenate it to the screen or just print it to the screen, I see that it has my instructions for starting port forwarding. And port forwarding, a single port, so I'm just going to read this so that we can get the technical definition of what port forwarding is. Single port forwarding allows you to make a port on your machine behave as though it is aimed at another machine on the same port. So it's making this connection, like I was saying, from your local computer to a computer on clone. And then this allows you to forward the hosted port for a service like RStudio or Jupyter Notebook on a node inside of the clone network on your local machine for access via your browser. So that's what we're going to set up. So remember, I wanted you to have 3 terminals open. So get your third one. This one's not logged into clone. This one's just on my computer, right? That's why it says Kristen Finch at Kristen's MacBook. Okay. So what I'm going to do is I'm going to copy this first thing. So it tells you what to do. It says on your workstation, copy this first line and paste it in here. Enter. I put in my password. I do my two-factor authentication. And now it looks like it's just hung up. It looks like it's just kind of stopped. And that's fine. It is working. Now the next thing is I need to point my browser at this location. So I'm going to copy that, open up my browser to a new tab, and I'm going to paste this in here. And now it's asking for my username. So then now we're in step 2, right? So I know that my username is FinchKN. And then you grab this password that it's generated for you. This will be different every time you start this up. So ways to mess this up. Sometimes people take this password and they put it into their port forward. And you don't need to do that. You need to put your UW password in there. So this is all just like logging into clone. That's what you use that for. And now your password, this is only for the browser part. You might have to retry. And it should open to RStudio. Hopefully quickly because we're live. Anyone have questions? Looks like maybe it's about to open. There it is. Has anyone successfully gotten RStudio to open up? Are you following along?
My RStudio one stopped running. I don't know why.
It was not what?
I submitted the S batch job, and then I could see it launch, and then it exited, and it just said R server exited 255.
Oh, weird. Do you want to try it again?
Oh, you know what? It's because I don't have the right SIF file in there.
Oh, yeah, yeah. So that was another one that you had to change. You had to customize your RStudio server dot job to go to
Got it.
tidyverse
Yep. Okay,
or
we'll
to
pop
one
it
of
up
these other
next.
ones, really. So actually, I think these R-based ones might not have RStudio, so that's just something to keep in mind. But the tidyverse one definitely does. And yeah, so Brian says that his has opened up and he's been able to load library dplyr, which is part of the tidyverse, so that's really great. All right, so what I want you to see now when you're looking at this is one thing, if you don't have the files pane or tab open, please click on this files tab right here. And you'll see that what you're looking at is your working directory that you set up. So all the files that you see there, including your R directory, are here, which is excellent. And then if we click on this checkpoint analysis.r, which is what I prepared for you today, it's just an R script that you can run. It's not the point that this R script does anything. If you're here, then you have your own R scripts. But I just wanted to run an R script this way so that you could see that you have tidyverse available to you because that is what this container has. And then you can run these, you can print your, plots and they will come up in plots and you can save as PDF. So I'm just gonna, highlight all of this and run it. And hopefully it won't be super slow. But yes, so when you load the library, you see all of the libraries that are included with your tidyverse container and what is masked. So this is really just a scratching of the surface of, what is possible here. And I'm anticipating that you're all gonna have some tickets and want my help in how to customize your environments, and I'm ready for it. So please don't hesitate to reach out. You're going to be a regular R user, we want to be able to help you. So like I said, it's loaded in your environment, all the things that we asked for it to load. We have our plots, which plotted in real time. So this was just some data that I pulled about checkpoint jobs and how many jobs ended based on what of these categories. So a large proportion of them completed, some of them failed. That's all that's showing this. And this was like how long it took. So a lot of things fail, in the first minute because there's some error with the code or whatever, and then some last. And then the red line is the checkpoint time limit. So that's all I wanted you to see there. But also, you can see in your files pane that since I saved these as PDFs that they have saved here, and I can click here and also be able to see the version of the output. So I can look at the plots on my plot tab, right? But I can also see the version of the output that I'm saving in the dimensions that I saved with the gg save command there. All right. So what I want you to do is leave this open. We're almost done. I only have one more thing to talk about, which is the Rscript function, which we have already seen in our definition file. We had the Rscript function, which allowed us to send a command of install packages to the R, which is inside of the container, and it installed our packages there and built our container that included that package. But one thing that I really love about the Rscript function is that if you have a script that can just run top to bottom, like I just showed you in here, but if it's running like very long time, like maybe it's a job that's going to take overnight to run or something like that, you could, set it up this way. You could use your same script and you could increase the time limit on the job, for example, to cover the amount of time that you need it to cover. And you could just never open up the browser window. Open up the browser window, highlight everything, set it to go, close the browser window, and it'll be running in the back. But there might be a more elegant solution that you don't have to do all of that logging in and whatnot. And I'll show you how to do that. So what I want us to do, we're going to use our RStudio-server.job as a template for the next part. So what we're going to do, we're going to copy that again, RStudio-server.job, but we're going to save this as Rscript-submit.slurm. That's going to be the new name of our file, which we're going to edit. So if I nano rscript-submit.slurm, we see it's all the same. I just want you to scroll down here. We don't need any of the stuff past this top material. I'm just trying to save time by starting with this top material. If you use Control key and K in nano, it will delete lines. So this is dangerous, but just delete all of that. We don't need any of this for right now. Okay, so you see what I've done here? So now I just have inside, I'll answer your question in a second, Devin, sorry. So inside of here, all I wanted to do is make this custom file and not have anything down here. And I'm just going to change a few things up top. I'm going to call this one Rscript instead of RStudio. I'm going to save all of this as the same. I'm going to change the time limit. This is where you could increase it and make it a really long job. But this is going to be a short job, so I'm just going to ask for 20 minutes. Yep, 20 minutes. And keep this all the same. So what you want to do to submit your script with the Rscript function to the container to run in R, you would use apptainer run, this command that we've already learned about before, right? But we need to bind to the file system, gscratch, so that it has access to that Rscript as well as the data files and everything else. And then we're going to pass our tidyverse container, tidyverse underscore v4.4.1.sif. And then instead of calling R, we're going to call Rscript. And then we're going to pass it our script, which is called checkpoint underscore analysis dot capital R. And what we're doing here, we're starting up our container and we're going to run a command binding our file system, and it's the tidyverse container. The command that we're running is Rscript, and then we're passing our script, our checkpoint analysis script. So I'm going to save this. So now I see I have my Rscript submit. I'm not going to submit it yet because I don't want it to overwrite these files because I want to show you that they're being saved again. So I'm going to mkdir a directory called archive. And I'm going to move the by state.pdf into archive. Actually, I'm smarter than this, so I can just do wildcard.pdf and it'll move all of my PDFs into archive. So that's just so we can see that since we're going to run this script and it's going to save those again, we're just going to be able to see that when it makes them anew. So what I want you to do is have your other terminal in frame as well, so you can see your new job come up. And I want you to use sbatch and then rscript submit.slurm and submit that so that you can see it when it starts. And then it starts writing your output file as well in the same format. Okay, let's see. So I'm going to start with Devin's question here. If we're doing development work, they're a way to specify no wall time. Also, if we're working on an RStudio job that is in this way, are we occupying an entire slice from our lab? If it is a long job, can we pass the job to checkpoint? Okay, great questions, great questions. So the wall time is required because the default wall time is short. I think the default wall time is only 1 hour. So you want to put something there so that you have a longer wall time. But if you have a slice with your group, then you don't have a wall time on your jobs unless you are running into our monthly maintenance. And you'll see an error in your queue on this side under node list. It will say node reserved for maintenance, and you'll just have to shorten that wall time to end before the maintenance starts. But if you have a really long job that needs to run an entire month, you could start it like the day after maintenance starts, and it could go for an entire month. So there's no wall time on that. The entire slice is not being occupied, and what is controlling that is the top of your script. So if we just head this script, so when you're setting up these things here, you're not asking for the entire node, you're actually just asking for 4 CPUs on the node. So most of the slices have 32 CPUs. So if your lab group has one slice with 32 CPUs, then you're only using 4 of them. So the rest of your lab can use the rest of the slice like that. But you can change these to use the entire slice if you want to. It's just that wouldn't be very kind to the rest of your lab mates because you'd be oversubscribing your job for what you don't need. So I would just look into the SLURM documentation to find out what's going to be best for your job. And then you either, when you're submitting this job, you can't go from, you can't like change the partition that a job is running on when it's running. You have to choose checkpoint when you're going to submit a job or compute or whatever it is when you're preparing this. You can't kind of like port a job to go over to a different partition. And so you have to set that up before you start. And the wall time on checkpoint is 5 hours and 5 minutes for CPU jobs and 8 hours and something for GPU jobs. Okay, can we make this generic with something like apptainer, run, bind, tidyverse, Rscript, one, or yeah, probably. Yeah, you probably could. So what Brian is asking, can you use other bash scripting to be able to, so I haven't tested that out, but my guess would be that you would do something like you would change your scripts. Well, we just try it. Let's just try it. So what I would do, instead of giving my script, I could do something like this, money one, like that. So it's taking the very first argument that comes after my submission. So let's try it. So X, yes, enter. So what it would be, we would do SBatch, and then we would give it our Rscript submit, like this, and then we would pass in our checkpoint analysis this way. Which I don't want to execute this just yet. I'll execute this in a minute. That's how I think it would look. I don't know if there's going to be an error, but what I wanted to say is that this job is done now. And if I go back on the browser and refresh, so here's the little refresh button over here on the side. I see again, I have my plots have been output, and that was from running the job again. Another thing that's been output is this rplots. So actually when you do that, it saves your session of all of, oh man. Oh, yeah. Okay, so it saved all of the plots that you generated in that session into one PDF called rplots. But they're not formatted how I was wanting them. All right, so back to, I don't know why it's getting mad. Anyway, back to what Brian was saying. Let's see if this works. So we're just gonna do this again. Did it work? Let's see. Oh, there, it's come up now in my queue. It's job 1415. So it's this one. So yeah, so it's working. So again, this output file is what was coded into our script to save all the standard output to one file. Yeah, so that's a great way to change this script actually to make it. So now you have Rscript and you can just send anything to the same container this way. So this is saving all of the output in your R console. So like what we had before, what we were running in the GUI version, it's being saved here. So now that's complete again. So everything that I asked to be printed to the console has printed here in the standard output. And again, if we clear and then look at the first 20 lines of my Rscript submit. So this line right here was how we say that. So another thing, if you also added a line here that you put sbatch -- error equals, and then you put another, like maybe you wanted to do it like this, then it would separate your output stream, your standard out, from your standard error, which could be helpful if you wanted to have any error messages printed to one file instead of everything being printed all to the same file. Okay, so we've already kind of gotten into the question time of this. That's all that I have for you today. We've gotten through all the exercises, but I'm going to be sticking around until 4 p.m. to answer any questions that you have. So yeah, thank you so much for coming and for attending this.